press your window button, which is directly left of zoom, and it'll look like this. Is your window button. What I usually do is I just go into this window. I always start by zoom 9, because that saves me the effort of having to it's kind of like getting in the ballpark, and then I refine in this window. So that negative 58, what should I call it, you think? Call it negative 60. I go to the next raw number down, or next integral number down, or power of 10, or power of 5. Not power of 10, multiple of 10, or multiple of 5 down. Okay? X max is at 34.1. What do you think? 35 or 40? I'll go with 35. That's totally fine. As long, you want to make sure it's big enough to make sure all your data's in there. And which it is. It is. Because our biggest data point, I think, was 21? I'm seeing a 21. So I think we're going to be golden there. You might even want to bring it down to 30. It's up to you. A scale, this is the most important one in my opinion. This is the one that talks about how wide the bars are. Right now the bars are 13 1/6 pounds wide. Strange number, but it's based on that TI algorithm. Change it to something logical, like 5. Change it to something logical, like 5. Now we might have to mess with these two, but I don't mess with them until I look at the graph. Now when you're going to graph it again, push the only button in the top row you haven't pushed yet, which is called graph. You don't want to press zoom 9 again, because if you press zoom 9 again, you're going to erase all that stuff you just did. And it's going to go back to that original window. Press graph, aha! There we go, now we're talking. Now we're talking. Now how is this graph like the previous one? How is it like the previous one? Alright, better. How is it unlike the previous one? Let's start with that. How is it different than the last one we just saw?
More bars.
Vivica, go!
The bars don't incorporate as much.
Good, good. You've got fewer data points between. You've got roughly 3 times as many bars-ish. They're now 5 wide. If you press trace now, they're only 5 wide. Negative 60, negative 55, 55, 50, 50, 45, and so forth. Good, good. Not as much stuff per bar. Good. How else are they different? Is that the biggest difference? Obviously, probably. How is it the same as the previous graph? Or similar to the previous graph?
The number's on 0.
Boom! Boom! Yes! This bar right here, that's the y-axis, which means x equals 0. So this is definitely pounds lost on the horizontal, and this is definitely your frequency up there. But what you didn't lose with this is the fact that that data is essentially a bell curve, is it not? That data is essentially a bell curve. Yes, that data is essentially a bell curve. And I say essentially, it's not a perfect bell curve. It's not perfect. It's got this spike that's too high over here, or maybe too low over here. But you're essentially a bell curve. You arguably have a tail going down here, and a tail going down here, and it's humping up here. This is why I collected your height data earlier. I'm like, let's take a look at this. Chances are your height data is bell-shaped, but I don't have enough of it yet to really see the bell flesh out. I'm curious to see what the next classes looks like when I add it to yours and see how that comes together. So, where's the average? Where's the average? Well, that's 0, right? That's negative 5. That's negative 10. There's your average right there. That's another reason to make the window so logical. That's another reason to make the window at a multiple of 5 or something like that, because then you can actually count logically where the line should go in. Now, it's not actually negative 15, it's negative 14 and some change. But call it negative 15. It's an ish. So do you see why I drew it there? I'm seeing some puzzled looks. I want to make sure I don't puzzle anybody at this point. All I'm doing now is counting tick marks. Your X scale, when you called your X scale 5, that means the end of every bar is 5 pounds down from the previous bar. So this is 0 because it's the y-axis. So this bar is 5 units wide. That means it has to be negative 5. Negative 10, negative 15, 20, negative 30. I mean, I wish I'd put that on there, but it doesn't. So you have to kind of know where they are. Cool? 5, 10, 15, 20, 25. There's your 21 pounder right in there. There's obviously somebody in there who I've forgotten now.
So how did you get that again?
How did I get what again?
That would be where...
I just counted down 5 each. Negative 5, negative 10, negative 15. When we made the X scale 5, we forced these bars to be 5 wide. And since this reference is 0 right here, we just know how to count down or up 5. Each bar is 5 wide. So we can use the number line to count us down there. Now, what do you notice about that? When you drop the average in, what does it do to the data set? It splits it roughly in half, doesn't it? It splits it roughly in half, which kind of goes back to our original argument about the percentage of those who lost weight. The percentage of those who lost weight, we said it was about 80%, right? Well, clearly this half lost weight, and clearly this chunk of this half lost weight, and these folks gained weight. So you can always get a visual of that. 80% of the graph is to the left of this vertical axis right here. And that's convenient, but it's inconvenient for other data sets because other data sets, unfortunately, aren't going to have necessarily that y-axis cutting through it. Suppose all the data is positive. Then you can't use the y-axis. So is there some way, maybe, of dealing with this guy, which we've now drawn on there, with this guy? What do you think? That's 16. How can we use that 16 with this?
You can use the negative 15 plus or minus 16 and see how many data points fall within that window.
Stop and start. Thank you.